Welcome to Lesson 6, Dictionaries. So dictionaries are used to store data in key-value pairs. They're changeable and don't allow for duplicate keys. And their values can be of any data type. So looking at this car dictionary, its keys are the attributes of the car, like brand, model, and year, and its values are the corresponding values for those attributes. So its brand is Ford, its model is Mustang, and its year is 1964. We can access a value from its key by using brackets and putting the name of the key inside. So this is how we would print the brand value of the dictionary. This would give us 4. To modify a value, we use the same syntax except set it equal to our new value as if it were a variable. The same goes for adding a key value pair. So if the key is not already in the dictionary, it will add it with this value. If it's already in it, as we saw before, it'll modify its value. When looping through a dictionary, its keys are returned. So if we were to loop through each quality in the car and print that quality, we only get the keys, we don't get the values. Write a function that accepts a list and returns a dictionary whose keys are the list numbers and whose values are those respective number squares. So we can define our function, which will just take a list. And we need to ensure that the keys of this dictionary that we return are the list numbers and its values are those numbers squares. So let's just first make an empty dictionary, just as we would a list. And we can loop through each item in the list and insert it into the dictionary. So for num in list, we can say squares dict at the key being number is equal to that number square. And that's it. Now we can just return that dictionary. We get 1 goes with 1, 2 goes with 4, 3 goes with 9, and so on. Write a function that returns the sum of all the values in a dictionary. So this will take a dictionary this time, and we only care about the values. So we can loop through this dictionary, but remember this will only give us the keys. So in order to sum the values, and we'll also set a sum variable, we need to access those based on the keys. So we'll say sum plus equals dict at that key. That'll give us the value and add it to the sum. Then we'll just return the sum. Here we'll get 18. Some useful functions we can use on dictionaries are keys and values. So calling keys on a dictionary returns a view object of the keys of that dictionary, and values returns the values. So a view object basically is what it sounds like. It gives you a view of the dictionary's entries, but you can't index that view. So you can't directly modify it. You can, however, loop through it, which is often good enough in most cases. But if you want it in a more accessible form, you can call list on it. So if we had this dictionary and we called list and dot keys on it, we would get a list with only the keys from that dictionary. Write a function that returns the sum of all the values in a dictionary using values. So we're just going to modify this. Instead of taking the keys and summing them based on those keys, we'll simply access the values directly by calling dot values, and we'll just add that value to the sum instead. So if we run this, we get 18 again. Write a function that accepts a string and returns a dictionary whose keys are the letters in the string and whose values are the amount of times each letter appears in the string. So this function will take in a string, and we need to count the letters in this string. We can just create a dictionary that starts off empty, and now we'll loop through each letter in the string. So here we actually have to check whether that letter is already in the letter counts dictionary. And if it is, then we can just add 1 to its current value. So letter counts and our key is just a letter. We'll add 1, just as if this were a variable. Else, we need to actually put that letter into the dictionary. Instead of adding 1, we just set it to 1 because that's the first time we're putting it in the dictionary. Now we'll return letter counts. Oh, and we should also set the string to lowercase beforehand in case they're capital letters. If we test this on the string hello world, we get a breakdown of how many letters are in here. So there's 1 H, 1 E, 3 L's, and so on. Given a dictionary of student scores, write a function that returns a dictionary that contains the students' names as keys and their grades as values, given the following criteria. So a score of 90 to 100 is an A, 80 to 89 is B, and you can look at the rest here. So we're essentially just taking these number grades and making a similar dictionary, except instead of numbers, we are using the letter equivalents. So convert grades, this will take in the scorebook. Now we'll loop through each of the students. So for student in scorebook, first we need to make our gradebook, which will be empty. We'll first get the score by using the key of the student, and then we'll just check its value against the different letter requirements. So I have these pasted here. Once you get the letter grade, we need to put it into the gradebook. The key stays the same, it's just the student, but its value is the grade. Then we'll return the gradebook. So converting this dictionary to the letter grades, we have B, C, A, D, and F. Create a function that will add a new country entry to the travel log. So here we actually have a dictionary of dictionaries. Each dictionary represents a country with the name of the country being the key, and we have visits and cities inside as attributes. So we want to be able to call something like this and have it add that to the travel log. This is very simple. We can just say, well, we'll take in the name, the visits, and the cities. Cities is a list. Just put that into the travel log. So the key is going to be the name of the country, and we can make a dictionary directly like this. So visits is going to be the value of visits, and cities is going to be the value of cities. Then we can just return the updated travel log, and if we test this, we see that we now have Russia with its attributes inside of here. Write a function that displays each country in the log of the previous program in the following format. You visited France 12 times, you've been to Paris, Lille, and Dijon. So we'll call this display log. And we need to get the dictionary for each country first. So for country in travel log, let's just first get the visits. So this gets us the dictionary for that country inside of the outer travelog dictionary, but we need to access the specific value inside of that, visits, and we'll do the same for cities. So we're just changing the key to cities instead. Now the string for the cities is a little tricky because we need the commas and the and. First, let's just check whether the length is greater than 1, because we don't need to do anything if it's just one city. So the string is going to be joined by a comma, but only up to but not including the very last city. So we can do that with slicing. We're going up to the last index, plus we'll have and if it is the last index. and we need a space here. So this will be the last city, which is at the index -1, else the string will just be whatever city is at the first index because there's only one city here. Then we just have to print out these statements that match what was in the problem. And this should actually be inside of the loop. Now let's call display log, and we get what was expected. Write a program that will collect the names and bids of different people. So it'll ask for each name and bid individually. It's like a secret auction. So here's an example. It asks for the name, bid, are there any other bidders? And this will keep going until someone says, no, there are no other bidders. And then the program will calculate who had the highest bid, and that will be the winner of the secret auction. We'll make a dictionary for the bids, and we'll also have a boolean to check if we're still bidding. While we're still bidding, every time we'll just get a name, we'll get their bid amount, and we have to convert this to an integer. And then we have to put that bid with the name into the dictionary. So bids, the key will be the name, will be equal to bid. And then we'll just say if input, are there any other bidders? If that's equal to no, we'll set still bidding to false. Otherwise, we don't need to touch it because it's just true by default. But now we actually need a function to find who the winner was once we stop. So we'll call this getWinner, and it'll take in that bids dictionary. The highest bidder, by default, we'll just say it's the first person. And to get that, we actually have to convert the keys of this dictionary to a list, because like I mentioned with the view objects, you can't index them. So we have to convert this to a list and get index 0. Now we'll loop through each of the bidders and see if anyone is higher than that highest bidder. So if bids bidder is greater than that highest bidder, then that person becomes the new highest bidder. And after this loop is done, we'll end up with the actual highest bidder, assuming there's no tie, and we'll return that. Now at the bottom, we'll call that function and print out the winner. So let's test this out. Yeah, what is your name? How much will you bid? I'll bid 100. Any other bidders? Yes. I'll put myself. I'll bid a lot of money. And one more person bidding $1. There are no other bidders. Of course, I'm the winner, and it gives how much I bid.